So now we're going to work through some examples to find probabilities of conditional events. So first we have a table that we've been given to us that gives us information about students that ate breakfast at a university and what their coffee preferences were and whether they were a freshman or a sophomore. And now from this table, we want to find the probability of if a student was selected at random from this group from 3 different events. The first one, we are told, knowing that the student is a freshman, the student prefers decaffeinated coffee. So this means we have been given that the student is a freshman. That is essentially what we are now going to restrict our sample space to. So we want to find the probability that they prefer decaf given that they are a freshman. So now I'm going to look at my freshman row because that is what we know has already happened. We know that they are a freshman. And from only that row, let's find the probability that they prefer decaf coffee. Well, there's 69 freshmen that prefer decaf out of the 237 freshmen. So this means that our probability that they prefer decaf, given that they are a freshman, is 69 out of 237. Which then we could round that to be about 0.2911 for their probability. The next one, we are asked for knowing that the student prefers decaffeinated coffee. The student is a sophomore. So now we have been given that they prefer decaf, and we want to find the probability that they're a sophomore. So probability that they are a sophomore given that they prefer decaf coffee. So now we have been given decaf, so that is the only part of this table that I'm going to look at. And from our decaf coffee, what is the probability that they are a sophomore? Well, 46 sophomores prefer decaf out of the 115 that prefer decaf. So this probability is going to be 46 out of 115. Which then, if we get the decimal of this will give us 0.4 for that probability. And then lastly for our table, we are asked to find the probability where knowing the student prefers regular coffee or does not drink coffee, the student is a freshman. So now we have been given that they're one of 2 things. They prefer regular coffee or they do not drink coffee. And from there, we want to find the probability that they're a freshman. So now we have been given they prefer regular coffee or do not drink coffee, which means we're going to be looking at both of those 2 columns. Those 2 columns are what we are restricting our sample space to. And within those 2 columns now, we want to find the probability that they are a freshman. Well, we have 23 freshmen that do not drink coffee and 145 that prefer regular coffee. So we can add those 2 together to get our total number of freshmen between these 2 columns. So 23 plus 145. And then we need to divide this by our total of the 2 columns. And we have 41 do not drink coffee and 341 that prefer regular coffee. So we can add those together. So that will give us 168 over 382, which then we can round this to the decimal, which will give us about 0.4398. So we have one last problem here to do an example for, and it's rolling 2 dice. And we want to find the probability of doubles given that the sum of the dice is less than 9. So probability of doubles given that the sum is less than 9. So the first thing that I'm going to do is figure out what my new sample space is. My sample space is only the sum, the 2 dice that add up to being less than 9. So let's highlight that on this dice table on the right. So 1 and 1, if we add those together, that's less than 9. 2 and 1, those are 3, adds up to 3. We have our dice that add up to 4. The ones that add up to 5, 6, 7, and 8. Everything else, the next ones, those add up to 9, 10, 11, and 12, and those are all greater than or equal to 9, so we don't want to include those. So I'm going to kind of just cross those off. They're no longer part of what I'm looking at here. So now my new sample space are all the ones that I highlighted because those add up to being less than 9. And now from there, let's figure out what is our probability of rolling doubles. Well, doubles means that we got the same number on the 2 dice. So we have 1, 1, 2, 2, 3, 3, and 4, 4. So there's 4 different outcomes in this event out of how many outcomes I have highlighted in yellow here that are less than 9. And we can count those up. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26 different outcomes. So this probability is going to be 4 out of 26.